Hey, Mr. Richards here. Today's 7th grade Unit 4 Lesson 10 Anchor Problems as we're going to start to tackle some inequalities now that involve negative numbers. So, in the chart below, one equation and three inequalities are shown. For each one, write the solution and use the space in the last row to check your solution. All right, so in the first one, if we had 3x equals 12, we solve those equations by dividing by 3 on both sides. And so seems pretty standard, right? Because this is going to cancel out and x is going to equal 4. And so x equals 4. And really no check for equations, I suppose. I mean, you could, I guess. A little different than inequalities. You can put in 4 here. So does 3 times 4 equal 12? Yes, 12 equals 12, and so yes, it checks out. What about the next one though? 3x is less than 12. Well, so far in these inequalities, I've told you just solve them like equations. Fair enough. Well, let's divide by 3 here. I divide by a positive 3 on both sides. 3 divided by 3 is 1, so that cancels out, and we're left with x is less than 4. All right, x is less than 4. And as we go to check this one, remember, let's pick a number that's less than 4 to check it. What if for x is less than 4, we pick 3? Well, in that case, then, you have 3x is less than 12. 3 times 3 would need to be less than 12. And sure enough, 3 times 3 is 9, and 9 is less than 12, so it checks. Yeah, so far pretty standard, it seems. We have 3x is less than negative 12. All right, going just divide by 3. I get it, Mr. Richards, divide by 3. And we get that 3 divided by 3 is 1, so that cancels. And so we're left with x is less than negative 4. And if x is going to be less than negative 4, to check that solution, pick a number smaller than negative 4, which is, I don't know, negative 5. So if 3x is less than negative 12, 3 times negative 5 would need to be less than negative 12. 3 times negative 5 is negative 15. And negative 15 is less than negative 12, so yeah, that works. For negative 3x is less than 12, though, let's divide by negative 3 on both sides. Fair enough. We're going to be left with then x is less than negative 4 again. All right, well, we already know for x is less than negative 4, that negative 5 works, because negative 5 is less than negative 4. All right, so negative 3, x is less than 12 is our inequality to start. So negative 3 times negative 5 needs to be less than 12. Negative 3 times negative 5 is positive 15, and positive 15 is less than, wait, no, it's not. 15 is not less than 12. So that doesn't work. But wait a minute. I solved this just like an equation, just like I did these other 3. I divided by this negative 3 on both sides. Okay, we did that right. We got the x, we got the less than. 12 divided by negative 3 is negative 4, okay. Negative 5 is less than negative 4, and we substitute that back in, and it doesn't work? What challenges arise with the inequality negative 3x is less than 12? Is this what you expected to happen? Well, it didn't match the pattern of the other ones, did it? I mean, the other ones I divided by the positive 3 on both sides, and was able to test numbers that were true when it worked out. But here it didn't, because here I divided by a positive 3 on both sides. Here I divided by a negative 3 on both sides. Huh. When I divided by the positive 3 on both sides, it worked. Divided by a negative 3 on both sides, all of a sudden didn't work. Interesting. Just to see. What if x isn't less than 4, negative 4? What if x is actually greater than negative 4? What's a number bigger than negative 4? How about negative 3? If we go back and check that, 3x is less than 12. Negative 3 times negative 3 would need to be less than 12. Negative 3 times negative 3 is a positive 9. And 9 is less than 12. So apparently, our solution needs to not be x is less than negative 4, but x is greater than negative 4. Huh. Something tricky is taking place when I divide both sides of an inequality by that negative number. Let's keep going and we'll explore why. In problem 2, Ralph is trying to solve the inequality negative 1/3 times the quantity x minus 48 is less than or equal to 15. He knows how to solve equations, so he writes the corresponding equation, negative 1/3 times x minus 48, instead of the less than or equal to, puts in the equal sign. So step A, solve his equation and plot the point on the number line below. Fair enough. If we have negative 1/3 times x minus 48 equals 15, instead we could distribute, or I could multiply by the reciprocal of negative 1/3 on both sides. So if I multiply by negative 3 on both sides, what that allows to happen is negative 3 times negative 1/3 is 1. So that cancels out. We're left with x minus 48 equals 15 times negative 3 is a negative 45. Then I can add 48 to both sides here. The minus 48 plus 48 is 0, so it cancels. And we're left with x equals 3. So I'm going to put an open circle here at 3. How is the solution to the equation related to the inequality? Well, if I put in 3 here, 3 minus 48 is negative 45. And negative 1/3 times negative 45 is 15. So I'm getting a 15 just like the right side. Now pick a number either to the right or to the left of the point you drew on the number line. Test this number as a solution to the inequality. What does this tell you about the direction of the solutions to the inequality? Let's start off by rewriting the original inequality, which was negative 1/3 times x minus 48 is less than or equal to 15. If I test, say, the 2, this would be then negative 1/3 times 2 minus 48 is less than or equal to 15. So negative 1/3 times, well, it'll be times, but 2 minus 48 is a negative 46, is less than or equal to 15. And when I take negative 1/3 and I multiply that by negative 46, I get a positive 15 and 1/3 is less than or equal to 15, but it's not. 15 1/3 is not less than or equal to 15, so 2 cannot be a solution to this inequality. Well, what about, let's pick the 6, because the 6 is on the other side. And you could pick a 4, a 5, a 6, 7. You could pick any number on the right side now. I'm going to pick the 6. So negative 1/3 times 6 for the x minus 48 is less than or equal to 15. We'll have the negative 1/3 times the 6 minus 48 is negative 42 is less than or equal to 15. And when I take the negative 42 times a third, I get a positive 14. And 14 is less than or equal to 15, which means 6 is a solution. What does this tell us about the direction of the solution to the inequality? That tells us we're going this way. That tells us we have to shade towards where the inequality is true. So I'm shading it to the right of the 3 here. Write the solution to the inequality using an inequality symbol. Well, it sure looks like to me this is an or equal to. So I have to shade the circle in as well. But this sure looks to me like I'm shading where x is greater than or equal to 3. So I had x equals 3 in my temporary equation, if you will. But my solution to the inequality was x is greater than or equal to 3. And it's interesting because it looks like my inequality symbol here turned. Interesting. It turned. And when you look at why, there is a little rule here. Whenever you multiply or divide both sides of an inequality by a negative number, that's when the inequality sign turns. And if we go back up to problem 1 real quick, notice everything stayed the same until I had to divide both sides by a negative number. That's when the inequality symbol had to turn, just like in problem 2. We ended up multiplying both sides by a negative number, so the inequality symbol turned from how it originally was, from less than or equal to greater than or equal to. Now that rule is a little bit tricky to memorize, which is why I would encourage you just to use the solve as equation and then check solutions method in order to get your inequality symbol correct. Couple more examples to go here. In problem 3, we're solving the inequality negative 2x plus 5 is greater than 1. Unsure how to treat the negative 2 in the inequality, so she uses the addition property of equality to rewrite her inequality. See her work below. Is it correct? Explain. Well, what she did is she added 2x to both sides to make this a positive 2x. She just moved it over. That works, because then she subtracted 1 and divided by a positive 2 and got x is less than 2. Is it correct? Sure. Sure. I mean, if she didn't, not knowing what to do with the rules, not wanting to have to test things, does it work? Sure. Because she's getting x is less than 2 here. Which means possible solutions for this include 1, 0, negative 1, and so on. Those are all smaller than 2. If you pick one of those numbers to test into negative 2x plus 5 is greater than 1, pick 0. 0 is a nice easy number. Negative 2 times 0 plus 5 would need to be greater than 1. Negative 2 times 0, that's 0. 0 plus 5 is 5, and 5 is greater than 1, so yes, this works. Checking the answer is a good justification. And so, what I'd like to do is to just show you the 3 different ways you can solve these inequalities that involve negative coefficients, is what these technically are. All right. So if we start off with the problem, negative 2x, we'll keep it simple, plus 4 is less than, we'll call it 8. Option 1 is to do the equation and number line check. And so rewrite this as an equation. Negative 2x plus 4 equals 8. I like to call that the temporary equation. That way we know that we're going to have to eventually get back to an inequality. And if we solve it this way, we could subtract 4 on both sides. This plus 4 minus 4 cancels out, and we're left with negative 2x equals 4. Then the opposite of multiplication is division. So we'll divide by negative 2 on both sides here. This cancels out and becomes just 1. So x is going to equal negative 2. Now I know negative 2 is going to be involved, and we're going to plot this on a number line here. And so if we put negative 2 here in the middle, pick a number bigger, and it doesn't have to be negative 1. It could be just a simple number like 0. Pick a number smaller, and again, it doesn't have to be negative 3. It could just be, say, negative 4. And then test these solutions. So our original inequality was negative 2x plus 4 is less than 8. Put in negative 4 and put in 0 and see which way we're going to shade. So negative 2 times negative 4 plus 4 would be less than 8 if negative 4 is true. Negative 2 times negative 4 is a positive 8, plus 4 would need to be less than 8. 8 plus 4 is 12. That's not less than 8. So 4 is not going to be, I'm sorry, negative 4 is not going to be a solution. What about 0? Negative 2 times 0 plus 4 would have to be less than 8 if 0 is going to be a solution. Negative 2 times 0 is 0, plus 4 would need to be less than 8. And yes, 4 is less than 8, so 0 is a solution. So that means we're shading towards the 0 and all those solutions on the right side of the number line. Now, since this is just a less than, we're not going to shade our circle. And from this point, we can then write the inequality from the graph, write our answer from the graph. X is greater than negative 2 is our solution to this inequality. So that's option 1. And quite frankly, that might be the most consistent way to solve these. Option 2. Do what we did above and use that whole additive identity idea, where we rewrite this inequality so that the negative 2 is no longer a negative 2. What do I mean? Negative 2x plus 4 is less than 8. If we add 2x to both sides here, this cancels, and we're left with 4 is less than 2x plus 8. And now we can just simply solve this. We got rid of all the negative coefficients, the negative parts with the x. If we subtract 8 from both sides, we're left with, whoops, the plus 8 minus 8 cancels, and we're left with a negative 4 is less than 2x. Divide by 2 on both sides. The 2 divided by 2 cancels. Notice we divided by a positive, so nothing really truly changes. Negative 4 divided by 2 is negative 2 is less than x. In other words, x is greater than negative 2, which is exactly what we got over here. X is greater than negative 2. So that's another option. The third option is knowing the rule. That whenever you multiply or divide, and the key here is both sides of an inequality by a negative number, you turn the direction of the inequality symbol or sign. And actually, I do like sign better as I'm writing that out. So inequality sign. In other words, straight up write it as it is. Negative 2x plus 4 is less than 8. Subtract 4 from both sides. That simplifies. We're left with negative 2x is less than 4. Notice we subtracted. That's not, the rule doesn't say change it. Now, as we divide by negative 2 on both sides of this inequality, we've shown y a couple times now. But as I divide by the negative 2, this becomes x, not less than, but x is going to be greater than negative 2 now, because we divided both sides of the inequality by a negative number. And so you have three options. I think the most consistent is using the equation to the number line check. The additive identity certainly works if you feel comfortable manipulating equations like that, adding the 2x, so you don't even have to deal with the negative coefficient. Or for those of us who can really learn, memorize, and accurately process a rule, you have the rule there as well. But any way you go about it, you definitely have to pay extra attention when you have negative numbers, negative coefficients with the variables. And that's it for this 7th grade anchor problems. Good luck.